Alright, you may recall that we defined reverse as follows. Define reverse lambda ls. If null ls, then we'll give it the empty list. Otherwise, we're going to append the reverse of the coulter of ls onto a list consisting of the car of ls. Car. Alright, let's run this and make sure it works. Reverse A, B, C, D. Alright, now we had to move 4 letters, so it seems like it should only actually take four operations, you know, to move that many. But watch this. In Ches scheme, I've got it tracing that same reverse function, and watch that. So we have to run reverse 4 or 5 times, and then you have to run append 4 or 5 or 4 times. So really, it's about twice as much work as you need to do, or it seems like you would need to do, and in fact that you do need to do, as you'll see here, as we defined the iterative version of reverse. So remember, iterative means that we have something. Well, it just means that you're not doing something like this, like you're not appending anything to the function call. You're not adding anything to it. You're not multiplying or consing anything to another function call. You're just recalling the function again, but changing some value in one of its variables. Alright, so now we'll define the iterative version of reverse, which is reverse it lambda ls, and we'll make an accumulator. Okay, now if null ls, then we're going to return the accumulator, because the accumulator will consist by then of the reverse list. Okay, now let's do reverse it, because in the iterative method you just call the function, you don't do something to it. So reverse it coulter of ls, and what are we going to put in the accumulator? The accumulator must consist of the reverse list. So if we cons the first argument of ls into the accumulator, say cons car ls into accumulator. Let's close that up. Alright, if we do that, then let's say we started it out with A, B, C, D. At first, yes, and when you call it, let's just redefine this one just to call it. To call it, you would do reverse it and then the list, and then for the accumulator you'd start with an empty list. You start with the base case in the accumulator. Alright, now let's run this. Okay, so well, let's check and make sure it works. Reverse it yes, reverse A, B, C, CBA. Alright, so how does this actually work? So reverse it, the accumulator is of course the empty list. Let's say okay, so first it's not, ls is not an empty list at first, so we call reverse it again on just BC, the list BC, and we cons A into this list here, the accumulator. So but next we have reverse it BC into the list A. Okay, now what's the next step then? Reverse it, we take the coulter of this list for the next value, which is C, the list containing C actually, and we cons the car of this list into that, which is B. So that is BA. Alright, do you see that? Oops, I'm sorry, the microphone fell off. Alright, so reverse it BC. Okay, and now you see next we'd call reverse it of just the empty list, and by now in the accumulator we have CBA. Because we'd con C into there, and once you call it with the empty list, then you just return the accumulator. Now let's paste these two definitions into Petit scheme. Alright, reverse. Oh, we have to trace it. Reverse IT. Reverse IT. A, B, C, D. And that. And there, we just call it basically 4 times. 1, 2, 3, 4. And the 5th time it doesn't really do anything, it just returns the list. Which is much better than this, where we have to call it twice as 8 times. So we have to do 8 functions. And with the append function too, remember the append function has to do quite a lot of work appending things. Not so much, yes, well, basically yes, the append function has to call cons 3 times to append this list to that, because remember it has to recreate this list and then cons it onto that list. So really the time used up for this is exponentially greater than the time used up on this iterative reverse.